Hi friends, once again KT sir is here with a new theorem from the chapter circle. Now in this video we are going to talk about theorem which is a converse of the theorem which we have studied in my last video. So before proceeding this video I would request you to check my previous video and then continue with this. Let's start with the theorem. Now theorem states that chords which are equidistant from the center of the circle are congruent. Now as I told it is a converse. So in this time they have given us the chords are equidistant from the center and we are supposed to prove the chords are congruent. Now see what is given to us. We have a circle with a center A. So let's write it down. Then the chords are there which are equidistant from the center. Chords, that means there are two chords. Let's take the chord PQ. Now since they are equidistant, so we need a perpendicular on that chord. I have taken AM perpendicular to chord PQ. Now I'll take one more chord RS. Again since they are equidistant, so the distance will take it as AN. So AN is perpendicular to RS. Now what is given? They are equidistant. That means AM is equals to AN. This is also given to us. What you are supposed to prove? You are supposed to prove the chords are congruent. Now which chords we are talking about? We are talking about chords PQ and chord RS and we are supposed to prove they are congruent. Now whenever we have to prove something congruent, we cannot prove it without the help of triangle. So there is a small construction. The construction is what? Draw PA and AS. Now see, we get two triangles, triangle AMP and triangle ANS. Now, in this both the triangles, major angle AMP is equals to major angle ANS is equals to 90 degree. That is given to us. Then, if you observe, the hypotenuse PA will be congruent to hypotenuse AS. Why? Radii of the same circle. And AM is congruent to AN. That is also given. So in other words, both the triangles has to be congruent by which test? Hypotenuse side test. You can also write this as RHS test. It's one and the same. Now see, when the triangles are congruent, their remaining elements are also congruent. Now when I say remaining elements, I am talking about the third pair of side. I am talking about side PM will be congruent to side NS. And the reason is CSCT. You can also write it as CPCT. Now, let's talk about AM, which is perpendicular to PQ. Now, since AM is perpendicular to PQ, I get PM is half of PQ. Same way, now AN is perpendicular to RS. So I can say SN is half of RS. और दोनों का रीजन तो सेम ही आएगा. क्या आएगा? Perpendicular drawn from the center of a circle to the chord bisects the chord. Now see, if you observe the equation 1, PM is congruent to SN. We got PM which is half of PQ and SN which is half of RS. Now since PM is congruent to SN, I can say half of PQ has to be equals to half of RS. Now half of gets cancelled, so we get PQ is equals to RS. In other words, we have proved chord PQ is congruent to chord RS. I hope you have understood this theorem. Now this theorem is not only limited to chords which are equidistant from the center of the same circle. It is also applicable for the congruent circles. That means you have a chords which are equidistant from the center in a congruent circles, then also they are congruent. So remember, this theorem is applicable for congruent circles as well. Now let's look at one sum. In adjoining figure, P is the center of the circle. Chord AB and chord CD intersect on a diameter at point E. If angle AEP is congruent to angle DEP, then prove that AB is equals to CD. Now see, P is the center of the circle, which is already given to us. We have the two chords AB and CD which are intersecting at point E and they are intersecting the diameter at point E. Sorry. Now they have given us angle AEP is congruent to angle DEP and you are supposed to prove AB is equals to CD. Now see, we have to prove the two chords are equal. Now when can we prove this? When we are able to prove that these two chords are equidistant from the center. Now equidistance के लिए अपने को perpendicular चाहिए. So for that we need a help of a construction. Now construction is what? Draw PM perpendicular to AB such that A dash M dash B Draw PN perpendicular to CD such that C dash N dash D. Am I clear till here? Now see, if you observe, we got the two triangles. Which two triangles we got? We got triangle PME and triangle PNE. Now our motive is to prove these two triangles congruent. So we can prove that PM is congruent to PN. Why? If we prove the PM is equals to PN, then we can say the chords are congruent because they will become equidistant from the center. So let's start. Now this time again it is a right angle triangle, but be cautious. This time only hypotenuse is congruent. There is no other pair of side congruent. So here hypotenuse side test will not be applicable. Please be careful for this. Now since it is a right angle triangle, one condition we know, angle PME will be congruent to angle PNE, and PE is a common side, that is a hypotenuse is a common side. Now since I told you we cannot go for hypotenuse side test, we have one more angle which is congruent, that is angle PEM will be congruent to angle PEN. Now if you observe, both the triangles will become congruent by SAA test of congruence. Now see, we have proved the triangles congruent. Now if the triangles are congruent, then remaining elements are also congruent. In these remaining elements, we are just going to talk about the side that is PM and PN. Now we know PM is congruent to PN. Now in other words, if PM is congruent to PN, we are proving that chords AB and CD are equidistant from the center P. And if they are equidistant from the center P, then I can say the chords are also congruent. How? Just now we have studied one theorem. What is the theorem? That in a circle, if the chords are equidistant from the center, then they are congruent. I hope you must have understood this sum also. I hope you are enjoying the videos. Do like, share and subscribe my channel. Also share these videos with your friends and do subscribe my channel for the regular updates of mathematics. Thank you.